knows everybody's name, right? You guys feel comfortable with each other? Okay, all right. All right, let's try with 6 of you. You're gonna have 6 girls or 6 boys come in front here. 6, if it only has to be girls, if the girls, boys, the boys. So no boys if there are girls. Okay, you sit. So only 6 girls first. Let's see. Now we're gonna try something. Let's see if this works, okay? He's gonna hold your hand. Everybody holds and make a circle. Okay. Okay. Now you guys are right now. What are you doing? You're facing to each other. Can you guys all face outward? Yeah. Now make your hands. No. Don't. Go back to the original position. Now your hands should not break. Okay. Now you reverse yourself. All right. Awesome. Okay. Your goal is to untangle this, right? Within the minimum amount of time and minimum number of steps. So you guys need to come together and think about what's the best strategy, the fastest way that you can do this. Okay? So you guys are tangled, right? Yeah, okay. Let's see how you can untangle yourself. That's step 1. Okay, that's easy. That was not the intent. Okay. No, there was something else. Sorry, I'm missing this. I think we've done this exercise earlier and this is not this easy. Okay. Then we should try something else maybe. Okay, you guys. Okay, go back. Sorry, let's try something else. I can't remember everything we did. It was a lot of fun, but it is not a one-step process. It takes at least 3-4 steps. That's too easy, right? Okay, we can. You guys have a paper, right? All of you guys got a paper, right? Everybody has a paper. Okay. See if we can do this here. 6, 12, 18. There are 20. About 20. How many of you are there? 20, right? More than 20. 26. Okay. So if we divide you into 3 batches, let's say this is going to be fine. Oh no. 10 and 10. Let's do 10 and 10. Right? Take a piece of paper. Let's say to 2 teams of 10 for now. 6 of you is going to be unfortunately out. So 6 here, 6, 8. Huh? We'll just try something. We'll see if it works. So I want 2 teams. And this doesn't need to be girls, boys, or anything. Got 6, 10. Can only be 10 this side and 10 this side for a second? I don't know. Am I doing it right? I'm not very smart today. My brain's not working well. So 6 and 4, or you can go 4 if you can go there. Or okay, 2 teams, right? So this 6 people and 4. I need 4 from here. Let's say the back 4. That's 10. 1 team. Okay. And here's 6, and you 3, and then 1 of you. So this team can wait. This bench can wait. You're gonna write 0 to 9. 10 digits. One person writes, so 0, 1, 2, 3, 4, 5, like this. Okay. So I want you to get up one paper, just a big number on your thing. So you start with 0, 1, 2, 3, 4, 5, 6, 7, 8, or 6, 7, 8, 9. Okay. Got 9 digits, 10 digits. Okay. Can you guys do that? Just take one paper. And same thing here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You're going to miss out. Okay. Can you do that? So write 0. Write a big 0. Okay. Write a big 1, 2, 3, 4, 5, 6, 7, 8, 9. Rameshwar, you're 8. You're not Rameshwar, right? Sorry? Chameshwar. Okay. Jameshwar. Okay. You're 9. Big 8, big 9. Okay. We got you guys. So one team comes here, one team comes here. We're gonna do a quick game, and as I don't know if it will work. Let's see if it works. I've never played this. Okay, you guys are facing me. Okay, and this is where it's going to become a little bit of a challenge because we have limited space. The rest of you come here. The other team comes here. So you guys go this way. Okay. All right. What we're gonna do is I'm gonna say a number. Okay. Which is going to be 6-digit number. All right. And you guys really have to assemble yourself in that 6-digit. Very simple. The faster one wins. Right? There are two teams. Is it easy? Did you guys get what I said? I'm going to say a digit, say a number that has 6 digits. You guys have to assemble among yourselves. You know, you can open this. You have to open your sheet. Look at me. Right? Open your sheet to me. Oh, rest of you can be judge here. Come here. Come on the dais. Come on the dais. I don't know if this is going to be, again, I don't know if it will be fun. It might be a flop show. But I hear this as a good game. Okay, you are the judge. Okay? One of you needs to be a timekeeper. I just need 2 of them. The rest of you can sit. So we're not 2 of you here on the thing. Actually, no, 3 of you. So 2 more. Come. The Gyan people will say, what these guys do every day. 9 or 9 or 6. Okay, so one of you is going to keep. Oh, yeah, you can do the stop. Okay. Oh, one of you is going to generate the number. And one of you is the judge who did it first. Okay? Or I will give the number first. The number will be a 6-digit number. It will not have any repeats in any of the digits. You guys have to decide quickly among yourselves who's who and quickly come around, right? Let's see who wins. Do you guys have enough space? I'm worried about the space here. Huh? When you say the number, we have to move forward. You have to move forward. The number should be visible. There should be 6 people here with the number in order. Okay? Right? Cool? Everybody knows everybody? Say hello, team. Yeah? Okay. All right. I'll be quick. Okay? Listen to me. I'll only say the number once. Ready? 3, 5, 4, 7, 1, 2. 7, 1, 2. 3, 5, 4, 7, 1, 2. 3, 5, 4, 7, 1. Done? You are the judge. Remember? You just stop and the time stops. When one person is done. Good. Who was done first? She's the judge. That team was done faster than you. Why did it take 16, 17 seconds, guys? So the goal in the next round is to reduce this to 2 seconds. Okay? Okay, are we going to replace these kids who are not playing? All right, they're going to come in and play. Or do you guys want to be judge? What do you like to do? Judge be better? I will play? Okay. Oh, yeah, right. Okay, you guys decide the rules. I'm just making it up. Okay? All right. Go back. So sorry, the space is the problem. You guys can move the chairs if you want. 17 seconds, guys. 17 seconds is a lot of time. Remember, 24 hours in a day. Right? You got to be efficient. This is all about teamwork. All about teamwork, right? Learning how to communicate better and faster. Okay, do you want to give the number next? Yes.
901
This team got done faster. Okay, one of you keep track of which team is winning. This team A, this team B. So the team B won first, the team A won second. First order was 17 seconds. Second one is? Okay. Now I'm going to shut up and you guys are going to manage the game. Okay? All right. Go ahead. Okay. Well, before I shut up, I can't shut up, right? Did you guys have a strategy? Do you guys have a strategy? Good. I'd like to hear that strategy later. All right. So we're going to go 5 rounds. We have 2 rounds, 3 more rounds, and let's see who wins, right? Okay. Keep going.
624,905. 624,905.
Who got done?
6.0.
You don't have to type at the time. She's managing the time. They got done first?
Both are managing.
Okay. Sorry. You guys are managing. I shouldn't be saying anything. Go ahead. You're not the judge. You guys were asked to come on top of the. Okay. So, how many did you guys manage? 6.03. And this one? 0.01 seconds. Ah, sadness in life. The judges are judges. You need to be better. I mean, be more fair. Don't look at your friends. Okay? Okay.
Ready? 137482.
137,482. 774.
No, this team got done first. Or did. Sorry, I'm not supposed to say. Which got done?
7.04.
I said human error.
Human error. Why don't we change the timers to the other? Now you do their team, you do this team. But I shouldn't be saying anything anyways. The team in front of you is. बेचारे पहले कर रहे हैं हर बार और नहीं हार रहे. The organizers are cheaters. We always feel that, right? When you. How many has it been? 4? I'm not doing anything. I'm the observer.
Maybe this thing because I have started the timer before she like once she started the numbering. So that's why they are getting more time.
Just observe both. You observe as soon as everybody
Oh, 8 seconds.
पूरा number हाँ as soon as she gets done saying the number.
Okay, we're gonna stop everything down. Okay, we're gonna play this game again. Okay, I mean, no, stop everything. You guys play here. I'm saying we're gonna nil everything that happened before this. Okay, because you guys have complaints. The organizers were not ready. We'll give them the benefit of doubt. Okay. This team says they've done partiality. That team says they're partiality. The observers say that the judges are partial. Inefficient. That's what you're saying. Inefficient. Hey, hold on. Do you guys want to set up some rules? You are the organizers. Set up rules.
नंबर बोल दो उसके बाद स्टार्ट होगा ये ठीक है और जब अगर किसी का रीअरेंज हो चुका है उसके बाद एक को डन बोलना है फिर ये जो टाइमर है वो रुकेगा अगर डन नेक्स्ट वाइड है तो कोई भी एक
मैं बोल दूँ.
एक को एक ही चीज
ठीक है वो ऑब्जर्व ठीक है then fine support.
हाँ ready 259381
Done.
6.4 7.9
Okay. Game number 1 done. This is a 3-game best of 3. So we have 2 more to go. Organizers, communicate. You are the organizer.
137482
137,482. 137,482.
4.9
Okay, last one. Last game.
We've already won 2 rounds.
624907
624,907.
4.9 4.9
Oh.
Okay, good job, guys. Thank you. Go back to your seats. Unfortunately, you guys didn't get to play. You got the chance. Good. All right. Now, I'm going to ask you guys something. Okay? The game's just not for the game. Of course, I need to give you a lesson in the whole process. The team A, right? What was your strategy?
the number if we was 3 I would look for 3 and stand
Okay. Did you guys communicate this to your team? Okay. What about B? What was your strategy?
Stand 0 to 8, 0 to 9, and then after the number was saved, then we have to for example 482. That was the number. So 4 will by himself will stand in the first, then 8 by himself by themselves.
And you guys did that themselves too. Okay? Did you guys communicate? Did you guys have a team leader? None of you had team leaders. Did you guys have people who would organize you, the people whose number was not called? Could you have done better? Let me ask this. What could you have done better? A and B. Yeah. Somebody from A first. You don't have an answer to what could you have done better. Yes.
This case was fixed combination of digits, 6 digits, 1, 2, 3. Like whenever the number says, we will go to our position.
There's always resource constraint in this world. Remember that. Always resource constraints. It's how you maximize your efficiency to work towards the resource constraint. What about you guys? What do you think could have done better? Okay. Your strategy was that everybody who is that number should go there they are. Your strategy was the same, right? Did you guys know each other's numbers? Did everybody know who was 3, who was 4, who was 5? In both teams. So you could go and sit next to that person or stand next to that person. Is that what you did? I didn't really observe it. Did the observers observe that? Huh? You did? Okay, good. So in a team, what did you learn? What did you learn? What was this lesson? What was the lessons from this small little game? Very simple game, has a lot of lessons actually. What would you learn? Coordination is important. Communication is important. You need to work in a team is important. Can't be lazy in a team. Never. Strategy is important. The most important thing of any event, any organization is strategy. That's what CEOs do. The team leadership of any company does strategy. Execution is somebody else. That's what I would have liked to see. I would have liked to see 2 of you being the CEOs, 2 of you being the executioners or operation guy, right? And then rest of you being quick, whatever. That's one way to do it. Other way to do it is to say, okay, here's your fixed part. You know the number. I go this, right? I mean, so whatever way you communicate. So I think you guys did that a little bit, at least somewhat, right? So you guys got it to less than 5. Good. But those are simple lessons one could have. There is sometimes some of you were confused to who's what, and you didn't really go on time there. What was the difference between the first one where you did 17 seconds versus the last one where you did what, 5, 6 seconds, 4 seconds? What was the difference?
The first time we did not have a strategy, we did not know where to start from. And we realized that we did not communicate that from. We didn't tell them that we start from this.
Okay.
That is what caused confusion.
Okay. So with our experiences, we become smarter. That's what you're saying, right? With our experiences, we become better in terms of strategy. So when you get a problem, what should you do? You should always imagine how you're going to run it in a mock run, right? That's not the right word, but okay, in a mock run, you would think so whenever you are tasked with something in your brain, or as a team, if you're in a team, if you are tasked individually, then individually, otherwise in a team, you should virtually run it in your head, okay? Or virtually with a team, okay, what will we do like this? This is a problem. Take 5 seconds to do it quickly before the thing starts, and then you're much better prepared. Preparation, mental preparation is the key to success a lot of times, okay? Simple things. Observers, what could have you done if you were at their place? What would you have done? Were they smart? Did they do the most efficient thing?
Because it was a surprise game and
Hmm.
the smallest whatever they could do,
Hmm.
they have done.
Okay. What were the constraints? Space, of course. Space is always a constant. There are always constraints in anything in life, right? What else? Was there any other constraints? What? The organizers were constants. Good job. I was wanting to hear that. This is why I want to bring it to organizers. Organizers, what could have you done better?
So at first we did not communicate better. That's why the time was different for the internet access.
Good job. Because I had to tell you guys to do what to do sometimes, right? First thing first, you guys need to communicate. People who are leaders, like you were essentially leading the two teams in some ways, you should have you should always be communicating, because confused audience is not a good audience, like my audience, right? So always communication is the key in that sense, right? So they need to communicate, but you need to first communicate with each other. You need to set up some rules. When I say you guys be the organizers, I know we have limited time, but you should have said, okay, let's decide who's gonna do, because she was measuring, you were measuring, there were differences. In fact, indeed, the first two times this team probably had won, where they were saying that the other team had not. Needed to have a strategy. Okay. All right. You could always seek help. There was helpers there, right? Finally, the most important thing. Both the teams said organizers are wrong. Didn't you? Both of you felt that way and you blamed it on organizers in a very minor way, but you did. Right? Always remember not to do that. Right? There's always flaws in anything that somebody does. But it's about you to first of all not complain. And if you want to complain, complain in a way that is nice and productive and constructive, right? A lot of us really, and I'm sure you've seen this in real life, everybody goes at each other, you did it wrong, you did it wrong. Blame game is never productive, never in a team. That's the most important thing. We Indians are very good at it. Okay, well, I shouldn't say Indian. Most people, it happens everywhere in the world, but blaming somebody else is never productive, right? Right? So I want you guys to never do that. If you want to give a feedback, like I ask for feedback, do it in a way that is helpful to the everybody together, right? I mean, I don't know what would have been the best way to do it here, but when you start blaming the other person, it goes in the wrong direction anywhere and everywhere. That's a start of an unproductive, non-productive environment in a team, because you guys all will be part of teams. You will either be part of the team, you will manage the team today or tomorrow or whenever you get to that, right? We can't be blaming, or your colleagues, okay, he didn't do his job, so I couldn't do my job. That's what you guys said. They didn't do their job, so I didn't do it. You guys probably had that internally, that he didn't go on time, otherwise we could have won it. How many of you thought that in your brain? No, not really? Good. But if you do, and I'm sure you do a lot of times, that this person could have done the job better, we would have won, right? Happens, right? In Indian cricket team, if they say, right, Kohli should have played better, then we would have won. Isn't that? That happens all the time in any team game. That's not productive, right? Okay, all right, let's do 3D Chromatin organization again. I had Santosh send you guys a video of High C. Did you guys get it? Okay, good. Because I felt bad yesterday. I was like, okay, I was not very good at this. So, you guys, and how many of you really watched the video? Everybody? Are you sure? So, who's going to come up here and explain High C? Huh?
We saw the video but did not understand.
You saw the video, but you did not understand anything. That's okay. It's okay. All right. So Mr. Salil will come up front and he's going to explain high C to everybody. He's volunteered for it. So now you will understand. What's your name? Adya. Okay.
Imagine a long strand, right? So there are two sequences of this strand. Now, the sequence, it's not just linear, right? It's all folded up into circles. So we want to find out that how often are these two sequences interacting with each other. So how do we do that? First of all, the cell is all looped in. So we use formatting ourselves. We use formatting, right, to basically cross-link these interactions. So let's try because bound up, and yeah, so you can see that we're cross-linking that DNA, and once the two DNA move close together, once they are cross-linked, we cut them with indentation side, and after that we mark them with biotin, and biotin is very specific, and it has a very strong interaction with streptococcus. So after that, we ligate those sequences or strands together, and then we purify them. So now, if you imagine what was initially in a linear strand, it was far apart. Now we have brought them together, we have locked them in place, and then we can sequence those strands. So when we map them, we get reads, which basically define how often those two sequences in the linear DNA are interacting in the loops or chromatin form. So that is basically.
Good job. Thank you, Salil. Anyone else? Something that Salil might have missed?
The heat map the two plots, which is like red color. So that red color is showing the binding of the and black color is showing the no binding or less binding.
Good job. You guys want me to go through this first or go through some basics of mechanism first? Should we go through high C first or mechanism first? Okay. Oh, actually, it is all here. I never realized this. I'm not at all technologically savvy, that means. Actually, we'll do the high C first a little bit, then we'll come back to this again, okay? For a second. So, as Salil was saying, right, and we discussed this yesterday, cross-link the DNA, got that. Cut with the restriction enzyme, okay, got that, right? That's clear, people? So cross-link means your protein's there, your whatever is holding them together is there, and then there is two cuts. You fill the ends. Why? What filling the ends mean? Do you guys know how restriction enzymes cut, right? So they'll leave an overhang. So that overhang, whatever 2 or 3 base pair or single base pair overhang, is now filled with biotin labeled DCTP or DNTP of sorts. Okay, biotin streptavidin is a great interaction. If you want to read more about it, you can. Okay, it's used in many processes. So you got that. Now this ligation, when he says ligate, is what I was referring to you guys as ligation under dilution conditions. So that will only help ligate things that are in proximity. So this is how these things get ligated together. Okay, fine, good. And then you share the DNA, deproteinase it. Deproteinase will remove things, share the DNA. You're essentially going to get 2 read pairs, one blue, one red. Blue belongs to one end, blue belongs to the other end, right? And then you sequence using the paired end. So you sequence from this end, and then you map each end to the genome, okay? These are valid pairs. So what he showed in this is only valid pairs, okay? Valid pairs which are next to each other of some sort. Okay. Actually, this goes there. Okay. This is another same diagram from another figure, another paper. I'm just showing you this just to appreciate that there are more things happen than just simply that. Okay. So same thing. You cross-link, digest biotin, fill in. You see some biotins will be on the end like this, right? Which won't be filled in. So you will get these kinds of fragments in the bottom. You're just not going to get only this kind. This is the only kind I showed in the previous figure, okay? Which is where biotin is in the center. Biotin might be on just the end, one end, and then it might be where your one end it might be in the middle where two ends are same, right? Just some of these two DNAs are right next to each other. You filter these reads out, okay, and you cut this biotin in the end. With a specific step, and then you do the pull down, and then you get these pairs. Only these are valid pairs where you have a blue and a red. The rest which are not. Okay. Now let's think about how this gets mapped. So he was talking about how this red and the thing, right? So once you have identified that these are the two regions, now think about the DNA, right? A linear DNA will always have things next to each other, will also come into that. So okay, I don't think I explained that very well. So there'll be things like this which are from two different strands or far apart, but there'll be things which are next to each other as well, right? Which are actually linear, which are actually next to each other in space. Not just space, but also sequence, right? So those sequence, so there will always be, these interactions will always be maximal, okay? These interactions between blue and red will be farther apart, right? And this is in a population, meaning there are many cells, and it's not precise, right? The resolution of this is actually not great. So therefore, you start getting, so okay, here, now let's try and understand this. There's a chromosome 1 on the x-axis, and y-axis, there's chromosome 1 on the x-axis. You're looking for self-self interaction, okay? So now, obviously, you're gonna, the two fragments that are linearly next to each other will show the maximum things. Those will also come as reads. Did you guess that? So therefore, the diagonal will always be red, because that's where the maximum interaction is, right? In a large population of cells where you did it, right? The maximal interactions will always be next to each other. So therefore, the diagonal will always be highly red. What is red? Red is just contact frequency. Contact frequency is a function of the number of reads that you sequenced from those pairs. Okay, that's it. So there's a lot of this is a very complicated math that goes behind actually high-C data analysis, and we don't need to get into this right now. But bottom line is, what you get by the end of all of that math is a contact frequency number that is equivalent to the number of reads that are in that blue and red, or the red and red, whatever, like fragments next to each other. So the two fragments that are next to each other, either linearly or in space, will always have the maximal, will come back, and that frequency of those numbers is proportional to the frequency is proportional to those number of reads that come in. Did you get the concept? It's very simple, right? The two things that are next to each other will always be next to each other. So they will preferentially have a lot more reads in them. But the other reads that are off diagonal, this is what I was mentioning to you yesterday. So this chromosome segment now have segmented the whole genome. So the way analysis works is, and even chromatography analysis works is, imagine the whole genome into a linear thread. You say 1 to 1000, 1000 to 2000, 2000 to 3000, like that. So there is 1000 base pair segments you take. That defines the resolution. Okay, the resolution is dependent on how many reads you sequence these for. So how many reads did you really get out of the data? In this case, it will be a 10 kb resolution, meaning 10,000 base pair. So you'll go 1 to 10,000, 11,000 to 20,000, 21,000 to 30,000, like that. And you will really now count the number of